So we're going to be going over these four questions from the worksheet. Okay, these are all the questions regarding minimum and maximum and point of inflection. So let us try to look into the first question here. So we want to first find out absolute minimum and absolute maximum. Now, whenever we are working on these things, minimum and maximum, what we have to work with is its first derivative. So let's try to look into the first question, A. So what is f prime? Uh, Here, derivative of 1 over x in fact becomes negative 1 over x squared. Now, derivative of ln of x is simply 1 over x. Now, here we have to combine them together to see, where we're going to have point of inflection and a critical point. So first, if you combine them together, as you can see, x squared will be the common denominator. Here we have negative 1, and here we're going to have plus x. Now, this can be equal to 0 if x is equal to 1, as you can see. When x equals 1, the numerator becomes 0. Now, this will be equal to undefined if x is equal to 0. So we have two critical points, which is 1 and the other one is equal to 0. Now, given these two, let us try to look into the number line. So but when you look into this one, our lowest value will be 1 over e. Given that e is around 2.718, so therefore our lowest value here for the domain of x is greater than 0. So in fact, our lower end would be 1 over e, simply. And then 1 is between 1 over e and e, so we're going to put down 1 over here, one of our critical points. 0, it doesn't really matter because it's not part of our domain that's given interval that's given to us. Hence, upper value would be e. Notice that we're not including e, but we x value of x is less than e. Now, then what's going to be happening? Let us try to look into this one. So when I try to plug in the value between 1 over e and 1, one nice value which you can plug in would have been, I guess, 0.5. First section, let x equals 0.5. The 0.5 is 1 over 2, which is between these two values. Now, then here we get negative 1 for the derivative. We are looking for the derivative of these values, negative 1, and plus 0.5 over 0.5 squared. But clearly you can see that the denominator will always be positive, but the numerator will be negative. So therefore, the entire value will be negative. And when x equals 1, we realize that the derivative has to be equal to 0. Alright, derivative is equal to 0 here. And between 1 and e, maybe we can set x equals 2. Then here we have negative 1 plus 2 over 2 squared. Clearly you can see that this is positive because numerator becomes 1. Now, then the fact that we are looking at the when x equals 1, we go from negative to positive. You see, the derivative is negative to positive. So therefore, we can definitely check up on the potential minimum point. Now, to see which one is absolute maximum or absolute minimum, we actually have to evaluate the values. So let us look at it. Let's call this one as x value, and let's call this one as y value. So we definitely have to always check up on the endpoint, And when x equals 1 over e, which is part of our domain, which we have to definitely check up on, and 1 seems to be our, 1 is our relative minimum, but we'll see if that's the absolute minimum. And then the other point, even though e is not included, but let us try to check up on the values of x and values of y around e. So we'll see what happens. When you plug in 1 over e, what's going to be happening? Here, it becomes 1 over 1 over e, and plus ln of 1 over e. Now, when you consider this one together, then this one becomes 1 over 1 over e becomes simply e, and then ln of 1 over e in fact becomes negative 1. Now, so e minus 1, so this must be around 1.718. And once you plug in 1 in place of that, then we get to have 1, and then plus ln of 1. Well, we know that ln of 1 must be equal to 0, so this is equal to 1. Alright, how about e? That becomes 1 over e plus ln of e. Now, ln of e becomes 1, and 1 over e, since e is equal to 2.718, we know that this one has to be less than, or maybe I can write it as 1 over e plus 1. But you will realize that this value has to be less than this value. So simply put, just to make an argument for you about that, 1 minus e must be greater than 1 over e plus 1, because this value is 1 over 2.718-ish. That means this has to be less than a quarter. But just to make sure, we can add 1. So e plus 1 over e, oops, minus 1 over e, and then must be greater than, adding 1 onto each side, 2. In fact, and you will realize that this is true because this is 2.718, and then 1 over e is definitely less than 0.718. So therefore, when you combine together, this will be true. So our maximum value seems to be right over here, and minimum value seems to be right over here. And this one is the absolute maximum. So e minus 1. But that happens when x equals 1 over e, because they're looking for the value of x. The absolute minimum is equal to 1, but when x equals 1. Alright, now second part is, what values of x is the curve concave up? So concave up, that means that we are looking at the second derivative. So let us try to figure out the second derivative, and then it has to be positive. So, looking at b, f double prime, the derivative of negative 1 over x squared becomes 2 over x cubed, and then here becomes negative 1 over x squared. Of course, when you combine them together, we get x cubed, and then here we have 2 minus x. Now, once again, just like before, uh, potential inflection points here is whether this can be equal to 0. That means when x equals 2, or undefined. That's where concavity may change. So, and that's when x equals 0. Now, but once again, since 0 is not part of our domain, what we like to do is this. We will use the number line just like before, but lower bound will be 1 over e, the middle will be 2, and upper bound will be e. Now, uh, let's try to test each value here. When we are looking at first section, just like earlier, we can test x equals. In this case, we can actually test x equals 1, and we will end up getting 2 minus 1 over x, 1 to the third power. Then this is definitely greater than 0, so this portion is positive. Now here, second section, maybe we can let x equals 2.5. Then you will realize that 2 minus 2.5 over 2.5 to the third power, we will realize that this will be negative. So in fact, concave up would be around here, from negative 1 over e to 2. And 2 becomes the point of inflection because sign changes. And between 2 to e, it will be concave down. So our answer will be, for what values of x is the curve concave up? The answer is when x is 1 over e to 0. That becomes our answer. All right, let us move on to the next question. So here we have find the coordinates of all points which tangent to the curve is horizontal. Now, here, tangent talks about derivative. Horizontal means that derivative has to be equal to 0. So let us try to find the derivative first. F prime here becomes, by the power rule, 4 over 3 times x to the, when you subtract 1, we get 1/3. Now, second one is plus 4 over 3 and x to the, here we get negative 2/3. Now, if you have to simplify this one, we will realize that 4 over 3 is common. And then we will realize that this will be x to the 1/3 power. And then here, second one becomes plus 1 over x to the 2/3 power. Now, in order for us to combine these two, what we can do is this. We can multiply this one by top and bottom by x to the 2/3 power. Then this in fact becomes 4 over 3 times here. We're going to have x over x to the 2/3. The first term becomes this one, and plus 1 over x to the 2/3. Now, if I have to simplify them further, then we get 4 over 3 times here we have x plus 1 over x to the 2/3 power. Now, when do we have first derivative equal to 0? It seems to be when x plus 1 is equal to 0. The fraction numerator has to be equal to 0. That means when x equals negative 1. Now, they are looking to find the coordinates of all points. Coordinate in this case then not only x value, but also y value too. So when x equals negative 1, what is the y value? Y then is equal to negative 1 to the 4/3 power plus 4 times negative 1 to the 1/3 power. Now, here becomes positive 1 because of the even exponent. Here on the other side becomes minus 4, which is equal to negative 3. So therefore, our final answer for A is negative 1, comma, negative 3. Now, second one, find the coordinates of all points at which the tangent of the curve is vertical line. Now, vertical line, that means the derivative cannot be defined, just like the slope is not defined. Now, that means when you look into this one, f prime is undefined when the denominator of the fraction becomes 0. So when x to the third power is equal to 0. That means x has to be equal to 0. Now when x equals 0, what's the value of y? Then you will realize that y is equal to 0 to the 4/3 power plus 4 times 0 to the 1/3 power, and you will realize that that's equal to 0. So in fact, our answer becomes 0, 0, which is the origin. So the answer for the second one becomes 0, 0. Find the coordinates of the all points in which the absolute maximum and absolute minimum occurs. Now, then what we can do here is the absolute maximum and absolute minimum has to be coming from these critical points. You will realize that the -3 and then 0 seems to be quite a good candidates. But since there's no boundaries, we have to look at the end behavior to see how far the function will be going up or down, and then let us see what happens. So let us try to look into the limit as x approaches positive infinity, only because they didn't give us any intervals. Then of x to the 4/3 power plus 4 times x to the 1/3 power. Now, then in this case, what's going to be happening is, as you can see, this will be increasing to the infinity, and then this will also increase to the infinity. Therefore, this will be in fact positive infinity. Now, but how about to the left side, as x approaches negative infinity? Now, then it becomes a little bit tricky here. Because what's end up happening is this becomes positive, while this one becomes negative. Now, then we might want to manipulate this one just a little bit further. That is this. What if we factor this one out? And then, since x to the 1/3 power is common, we get to realize that this is limit as x approaches negative infinity. Here we have x to the 1/3 power is common. Then we get to realize x plus 4. Now, then it might be a bit better for you to see, because this portion is negative, while this portion is positive. The product between negative and positive, negative infinity and then positive infinity, simply becomes negative infinity. So in fact, when you look into this one, as the end behavior of this function, left and right, will in fact far exceed -3 over 0. So we realize that these are simply the the relative minimum or relative maximum, but in fact they cannot be absolute minimum nor absolute maximum. So in fact there is none. Becomes our answer. Alright, so but I think there's a small mistake. When as x approaches negative infinity, here we have this one becomes negative, my bad, and this one also becomes negative, so it becomes positive. Now, that means whether you go for the left side or right side, both of them will be approaching positive infinity. There is no absolute maximum, but absolute minimum would be the one of these two lower values, because those are the critical points. So in fact, absolute minimum becomes uh, -1 comma -3. This will be the absolute minimum. All right. Now, then second question, D, for what values of x is the function concave down? Now, to see whether something is concave down or not, we have to look at f double prime. F double prime here, given that f prime is this value, what we can do is this, was 4/3 and x to the 1/3 power plus x to the negative 2/3 power. So in fact, when you try to take the derivative of this, which is the second derivative, then becomes 4/3, and here becomes 1/3 x to the negative 2/3 power, and then second one is minus 2/3 and x to the negative 5/3 power. Now, here, if you were to simplify this one further, then we will end up getting 4/9. I'm factoring out 1/3 from each side. And here we have 1/x to the 2/3 power. And then second one is minus 2/x to the 5/3 power. Now, to make the common denominator, I need to multiply top and bottom by x to get x to the 5/3 power. And here we have x minus 2 over x to the 5/3 power. Then you will realize that this will be equal to 0 when x will be equal to 2, which is one great candidate for change of concavity, or when this will be undefined, when x is equal to 0. All right, so then let us try to look into these two questions, these two cases. So once again, we're going to try to draw the number line, and 0 is one value, and then 2 is another value. So let us try to test each section. First section, when I guess we can consider x equals -1, maybe. When x equals -1, we will get -1 minus 2 all over -1 to the 5/3. Now, then this we will realize that numerator is less than 0, and denominator is also less than 0, but negative over negative become positive. So we realize that this is greater than 0. So this is positive. Between 0 and 2, we can plug in one second section. We can have x equals to 1. Then we get to realize 1 minus 2 over 1 to the 5/3 power. And you can clearly see that numerator is negative while denominator is positive, so this will be less than 0. So we have negative concavity. Now third section can be when x equals 3, then 3 minus 2 over 3 to the 5/3 power. You can clearly see that this is positive. Then the question was asking for concave down. Then function is concave down between 0 and 2. So we can simply write it as when x is greater than 0 or less than 2. That becomes our final answer. All right, we're going to stop for now. And part 2 will cover question number 3 and question number 4. Have a nice day, guys. See you tomorrow. Bye.